everything.
Finish that last assignment. You can say use photo messages in class.
Okay, so there's certain kinds of problems that we can't just use normal algebra to solve, like this exponential equation right here. How would you figure out 3 to the what equals 54? That's the problem. Like 3 to the third is 27, 3 to the fourth is 81. So the answer, I know, has to be somewhere between 3 and 4 to get 54, or oops, this is supposed to be 81. This answer has to be somewhere between 3 and 4 because this is between 27 and 81. So what they did was they made a calculator to be able to do it. I'm explaining, yeah, we're not actually solving these quite yet, but I'm kind of explaining why we need this function. Okay, to solve this, you would have to do, this would be called log base 3 of 54. Okay, I think we're actually solving this tomorrow, not today, but, and there's buttons on your calculator that you can push to figure this out. So logs, it's called the logarithm function actually, but I'm just gonna say log. Logarithms are used to solve for exponents, if your variable is an exponent, okay? And here's how it works. Let's do one we know. Let's say 3 squared equals 9. So in a logarithm function, this first number, the base, goes right here, little 3. The answer goes next, and then it's the exponent, equals the exponent. So it's log base 3 of 9 is 2. Or the common log, no, log base 3.
Am I dumb? Can you help me?
Okay, so what I did, think of it like this. If this is like A, B, C, what I did was A, C, B. Does that make sense? A, B, C, the order switches to A, C, B. We're not plugging in the calculator yet, I can plug it.
Yeah.
So this is more like what we're going to do on number 1. Just write it down. We're not solving anything right here, we're just rewriting an exponential equation into a logarithm equation. Okay. That's probably enough to get us started, then I'll talk a little bit more in a second.
Where did 2 come from?
The exponent, right there.
Oh,
Oh, actually, before we get started, I'll mention one more thing. If it just says log, which probably most of your calculators have a button that just says log, like let's say of 100. If they put no number down here, guess what number is down there?
1.
You'll probably won't guess. It's a 10.
What?
Okay, it's called the common log. I don't know why, common logarithm. So maybe you guys can answer this. This means 10 to the what equals 100? Nope.
2.
Yeah, I mean it would be 2. 10 to the second equals 100. So if you guys plug in your calculator log 100, it should say 2 basically. Anyways, let's try number 1.
That sucks.
Okay, 5 squared equals 25. So you do log base 5, so it starts off with the same number, of 25 equals 2. You guys see how that works? When you're zooming on right through there. David, how about number 3?
Log base 3, 1 over 9 is equal to
All right, Kale number 5.
Log 10.
Okay, yeah, log base 10. If you have log base 10, you can kind of skip it. Just and then what?
1 million
Right.
equals.
Common logarithm of 1 million equals, what was it, 6? Alright, Cooper, number 7.
Log of 6.
Log
6
base
equals
6. Log base 6 of 6
Of
equals
6.
1. Yeah. So it's kind of like saying 6 to the what power equals 6. The answer is 1. Okay, number 9, we're going the opposite direction. So remember how I said it was ABC turns into ACB? It's pretty much the same thing when you're going the opposite direction. ABC is going to turn into ACB. So on number 9, the base is 3, so that comes first. And then the exponent, the last thing, the C, comes next. So 3 to the 4th equals 81. And your answer should make sense, right? 3 times 3 times 3 times 3 is 81. That sounds reasonable. Okay, Ty, how about, you want to try number 11?
Log. I'm looking at number 8. Do I just
Go ACB. So on 9 through 18, we're turning them back into exponential. We're turning the logs into exponential equations.
so it's 3 to the negative 6
Yeah.
equals 1 over 729.
Yep, that is it. Luke, 13.
13 is,
It's
well,
a-
we're missing,
Yeah,
it's just 10, isn't it?
that's right, yeah.
So it's 10, negative 4, and then it's equals 1 over 10,000.
Correct. Alright, Elena?
So it would be 0.1, so 0.1 cubed equals 0.00.
Yeah. Elena, do you want to try? I got cadence.
1/4 of 30 equals 1/4.
Yeah, on this one, we should put parentheses around the 1/4, otherwise it looks like we're cubing the 1. So anyway, 1/4 cubed equals 1 over 64. See why we're doing 30s? Don't take any time at all.
I don't want to do that. Actually, I feel like things are just with me on the 30, or should we look at 17?
It's 2 to the
It's just something down here, just slow down.
Okay.
If you turn it right down, you can write down.
Be yourself.
Can't do it on the spot.
On 19, now there is a way to do this on your calculator. I'm not sure they wanted you to do it on the calculator with the tricks yet.
I thought we did it anyways.
Alright. Okay. So, let's change it into exponential form first. What is, Crystal, do you know what that is as an exponential equation? 19.
Is it?
You try?
Do it.
You wanna try?
Wait, it doesn't have one grade. It doesn't have an equal.
Right, it doesn't. We put it in there.
Oh,
Oh, yeah. Yeah, I see what you're saying. Sorry, my bad. Yeah, it's a little bit different. So it's log 256. Yeah, you could say it's equal to x. That's the unknown. So it's 2 to the x equals 2 to the what equals 256.
16.
Yeah, if you plug in 2 to the 8th, it should work. Now,
Oh, it's 2 to the 8.
yeah. You can't just plug in log 256 because the base would be wrong. So you would get the wrong answer if you plug that in. There is something to plug in, but it's supposed to be tomorrow's assignment. So they didn't tell us yet. But anyway, 2 to the 8th is 256. So the answer is 8. You guys all know where your power button is at on your calculator, right? Okay, 21, this might be easier, I don't know. Brock, what's 21 as an exponential equation?
7x equals 343.
So if you do 7 squared, that's already 49. And if you do 49 times another 7, it's almost 50 times 7, so it's about 350. So this is just 3 of them. You could check it by plugging 7 to the 3rd in your calculator and making sure it equals. All these will come out nice and neat. Now, if I just made up some random numbers, I would get a weird decimal answer, which is where the calculator would, or the log function on your calculator would be necessary, but these will all come out nice and neat. 23, Justice, what's 23 as a exponential function?
3 to the x equals 127, which is -3.
Right. You guys remember that negative exponents flip. 3 to the 3rd is 27. 3 to the negative 3rd is 1 over 27. Okay, 25. Jaden, do you know what that is and that does an exponential?
10 to the 5th equals 100,000.
Okay, yeah, 10 to the what equals 100,000. 10s are easier because, well, if you're going to 100,000, each time you multiply by another 10, it adds another 0. So it just takes, basically the number of zeros is how many 10s you need. $27. Josie,
What?
you know how to write 27 as an exponential
Okay.
equation?
B to the x power equals b.
Alright, so b to the what equals b?
0 or 1.
1. Anything to the 0 is equal to 1. Anything to the 1 is equal to itself.
Okay.
So it's just 1. And David, how would you write 29 as an exponential equation?
So
This one's kind of cool. It's going to screw us up.
so it's b.
And instead of using x on this one, because I used x, let's put like a little question mark right there. B to the what equals b to the x. It's basically what it would be. So, what's the what have to be?
X.
X. So x is the answer. Kind of doesn't work because we were using x on the other ones for a blank spot, but they used x for their thing. So anyway. So 30, no, never mind, I'll let you guys try to figure it out. If you have questions, you can